Okay, so picture this. You come home one day and your beloved German Shepherd, your best friend, is acting a little off.
Yeah.
Having trouble walking. Maybe their vision seems a bit blurry, and then boom, you find out it's a massive skull tumor.
Right.
Surgery seems impossible. But what if I told you there might be a way, and it involves 3D printing?
This is a really cool case study we're diving into today. It's from Frontiers in Veterinary Science, and it reads like something out of a sci-fi novel. We're talking about a 12-year-old German Shepherd with a complex skull tumor who was treated using cutting-edge 3D printing technology.
And I know our listeners are all about that cutting-edge tech, so we're going to make sure we unpack the nitty-gritty of this 3D printing process and really get into the limitations as well. So let's start with the tumor itself. This wasn't just some run-of-the-mill growth. This thing sounds like it threw the textbook out the window.
Yeah, definitely not your everyday tumor. We're dealing with what's called a multilobular osteochondosarcoma, or MLO for short. Yeah, it's a mouthful. And basically, it's an aggressive type of bone tumor, and this one was lodged right in the dog's skull.
Oh, wow. Talk about a bad spot.
The worst. And the paper really emphasizes just how massive this thing was. 5 centimeters by 6 centimeters by 8 centimeters.
No.
It was huge. And all that bulk was pressing on the brain, specifically the cerebellum and the occipital lobes, which is impacting the dog's vision and coordination.
Oh, no wonder the poor thing was having trouble walking and seeing. That's more than just a lump. It's like this tumor was impacting the dog's entire world.
Yeah.
So with something this aggressive, this big, and in such a delicate location, what were the options even? Traditional surgery must have been off the table, right?
Yeah, you're spot on. Traditional surgery was deemed way too risky.
Yeah.
The chance of complications of damaging critical brain structures during removal, it was just way too high a risk. And that's when this incredible veterinary team decided to turn to the world of 3D printing.
Okay, now we're talking. But I have to ask, how do you even begin to plan a surgery when the margin for error is basically zero? Did they pull out a magic wand?
Well, not a magic wand exactly, but pretty close. First, they took super detailed CT scans of the dog's skull, mapping out the tumor's exact location and size. Then they used all that data to create a 3D digital model.
So they basically built a digital twin of this dog's skull before even thinking about picking up a scalpel.
Precisely. And having that 3D model let the surgeons plan the entire procedure virtually, which is incredible.
It's like practicing a complicated dance routine in virtual reality before you hit the stage.
Yeah, exactly. They could map out the safest possible route to get that tumor out and minimize the risk of damaging any vital structures.
Talk about minimizing surprises in the operating room. That's amazing. But they didn't just stop there, did they? Because you got to replace that missing chunk of skull once the tumor's gone. Did they just pull one off a shelf?
That's the really cool part they didn't. They 3D printed a custom implant for this dog.
Wait. They printed a piece of skull. Okay, now that is some serious science fiction stuff right there. What did they even use to print something like that?
They used a material called PEEK, which stands for polyetheretherketone. It's a mouthful.
Of course it is.
But basically, it's this incredibly strong yet lightweight material, and most importantly, it's biocompatible, meaning it plays well with the body's own tissues.
So no chance of the dog's body rejecting its fancy new skull part. That's amazing. But why PEEK specifically? I mean, there's got to be other options out there, right?
Oh, there are definitely other materials they consider, things like PMMA, titanium mesh, even hydroxyapatite. But the paper does a good job of highlighting that each material has its downsides.
Okay, so it's like material science roulette. What were the pros and cons they were weighing?
Well, take PMMA, for example. It's cheap and easy to get your hands on, but it's tough to mold into complex shapes, and this dog's skull was anything but simple. Then you've got titanium mesh, which is super strong, but it can mess with follow-up imaging, which you really need for monitoring the dog's recovery.
Oh, that makes sense.
And then there's hydroxyapatite. It's great because it actually promotes bone growth, but it can be brittle.
So it sounds like PEEK was kind of the Goldilocks material here, not to this, not to that, just right. But let's talk about the actual printing process itself. I mean, they didn't just hit treadle plus P on a regular desktop printer, did they?
No, not quite. They use a specific type of 3D printing called material extrusion, sometimes called fused deposition modeling, or FDM. Basically, think of it like a hot glue gun.
Okay.
But instead of glue, it melts and extrudes a thin filament of this PEEK material, layer by layer, based on that digital blueprint they made of the skull implant.
So a high-tech hot glue gun building a skull piece, one super thin layer at a time. That is wild. But what's the advantage of doing it this way compared to, say, just carving the implant out of a block of PEEK?
Well, the main advantage is that this material extrusion, it gives you incredible precision and control over the final shape. And that was super vital for replicating all the intricate details of a dog's skull. Plus, it works really well with material like PEEK.
Okay, so they've got their super detailed plan, their custom-made piece of PEEK skull ready to go. Time to put it all together, right? Did they wheel in a robot surgeon for this part?
We're not quite there yet, although knowing how fast technology moves, who knows, right?
Right.
But for this case, they still needed a highly skilled surgical team, but those 3D printed elements were definitely their secret weapon going into the operating room.
So going into surgery, they've got their incredibly detailed roadmap, this custom implant. But even with all that prep, actually removing a tumor from this part of the skull, I mean, that's got to be incredibly delicate.
No doubt about it. The stakes were high. And this is where those 3D printed guys we talked about really come into play. They basically acted like surgical GPS, helping the surgeons navigate the skull and making sure they were removing the tumor with absolute accuracy while minimizing any damage to the surrounding tissues.
Okay, now that is next level precision.
Yeah.
But with something this intricate, there had to be some challenges, right?
Yeah.
They say no plan survives contact with the enemy, and in this case, the enemy is a very complex, very much alive being.
You hit the nail on the head. The paper actually highlights one specific challenge they ran into.
Oh.
The bone in one particular area ended up being way more fragile than they anticipated based on the CT scans and the 3D models.
Oh, well, so what did they do?
Well, it meant the surgeons had to adjust on the fly a bit, really relying on their skill and experience to make sure that custom PEEK implant fit perfectly.
That's a good reminder that even with all this incredible tech, surgical expertise is still absolutely paramount. So surgery, complete tumor out, new skull piece in place. What were those first few days and weeks like for this lucky dog?
Well, first of all, the surgery was a success. The dog pulled through like a champ. And here's where things get really interesting. The dog's vision, which remember, had been severely affected by the tumor pressing on its brain, it actually started to improve.
Wait, are you serious? So not only did they remove this massive tumor, replace part of its skull, but they potentially restored its sight. That's incredible.
It's a testament to just how remarkable the brain's ability to recover is and to the precision of the surgery itself.
Yeah.
I mean, we're talking millimeters here, a couple of millimeters off in the wrong direction. Could have been devastating, but...
But there's always a but, isn't there?
Well, the dog did require several weeks of close monitoring and care. And remember how we talked about PEEK being good for imaging?
Right, because it doesn't interfere.
Exactly. That was super critical during recovery.
Yeah.
The follow-up CT scans showed that the implant was settling in really nicely, no signs of rejection, which is a major win.
That is a major win. Okay, so good news on the implant front. What about the tumor itself, though? I imagine the fight wasn't completely over just because they removed the main mass.
You're right, especially with a type of tumor as aggressive as MLO. The research paper talks about how they tackled that using a specialized chemotherapy regimen called metronomic chemotherapy.
Metronomic chemotherapy.
Yeah,
It sounds almost musical.
Mm-hmm.
What's the thinking behind that approach?
Basically, it involves giving lower doses of chemo drugs, but on a much more frequent schedule, often continuously, compared to the traditional kind of chemotherapy, which is more intermittent.
So it's like a steady, gentler approach, rather than hitting the system with a sledgehammer all at once.
Exactly. And the idea is that this constant low dose helps starve the tumor of the blood vessels it needs to grow, while also minimizing the harsh side effects that you often see with the traditional higher dose chemo.
Oh, wow. So it's a win-win.
Exactly.
That's amazing. So what was the outcome for this brave pup? Did it get to go home and chase squirrels again?
So the good news is, yes, the dog did get to go home and enjoy a good chunk of quality time.
Whoa.
The combination of the surgery and this metronomic chemotherapy seemed to do the trick, no signs of the tumor coming back.
That is absolutely amazing. Talk about science for the win. But I imagine this wasn't just about buying this one dog some more time. This case has much wider implications, right?
Absolutely. This study, even though it's just one case, it really opens our eyes to the possibilities of using this technology, this 3D printing technology in veterinary medicine, particularly for these really complex surgical cases.
Yeah. It's like we're opening up this whole new chapter in how we can approach veterinary care, where we can create these super customized solutions for our furry patients. But I do have to wonder, with all the excitement around 3D printing, What are some of the limitations we need to be aware of? Because it can't be all sunshine and roses, right?
You're right. Every technology has its challenges. I think one of the key limitations, and this is something that comes up with a lot of cutting-edge medical technologies, is cost.
Right.
The equipment, the materials, the expertise needed to design and produce these 3D printed implants, it's a significant investment, which could be a barrier for some veterinary hospitals and pet owners.
It's that classic dilemma, balancing this amazing innovation with the very real-world realities of cost and accessibility.
No.
But assuming those costs do come down over time, which hopefully isn't a big assumption, what are some of the other hurdles?
That's the burning question, isn't it? And yeah, you're right. Cost is often the first domino to fall. But even if we can get past that, there's still other things to consider, like the time it takes to create these custom implants and the need for specialized training for veterinary professionals.
Right. It's not as simple as just buying a 3D printer off the internet and hitting print.
Exactly. You need skilled individuals who really understand the technology, the materials, the nuances of each individual case. And of course, let's not forget the need for more research.
Right.
This case study offers us this super compelling glimpse into the potential of 3D printing, but we need more data, we need more long-term studies to really fully understand its long-term effects, any potential complications, and how it might apply to different types of cases and animal patients.
So it's about refining the process, gathering more evidence, and ultimately just making sure that we're using this incredible technology responsibly and effectively.
Okay. But I want to zoom out for a second because we've been so laser focused on this one amazing case study. But what does this mean for the future of veterinary medicine as a whole? Like, where do we go from here?
That's the ultimate question, isn't it? But I think what we're seeing is a shift towards this idea of personalized medicine, and not just in human healthcare, but for our animal companions as well.
Yeah.
This case really drives home the point that we're not limited by what we can achieve with traditional methods anymore.
We can tailor treatments to the individual patient, their specific anatomy, their needs.
Exactly. And as 3D printing technology continues to evolve, becomes even more precise, more affordable, more accessible, it really has the potential to completely revolutionize how we approach a whole range of veterinary issues.
Wow.
We're talking everything from bone fractures to joint replacements, dental and reconstructive surgeries. It's really exciting to think about the possibilities. And speaking of pushing those boundaries, there was one more thing that I wanted to touch on from this research paper, and that was some of the potential limitations of the specific type of 3D printing they used in this case. That material extrusion method.
Oh, yes. They get into some of the really technical nuances there, which I think is where it gets extra interesting.
For sure. And we talked about the benefits of material extrusion, but like with anything else, it has its quirks. And one thing they mentioned was something called anisotropy. Now, I'm all for a good, complicated scientific term, but break that down for us. What does that even mean, and why is it important in this context?
It's a great question. So anisotropy, in the simplest terms, basically means that a material can have different properties depending on the direction you're looking at it.
Okay.
So think about a piece of wood. It's much easier to split along the grain than against it, right?
Okay, that makes sense.
Yeah.
So how does that apply to our 3D printed skull piece?
Well, with this material extrusion method, you're building the implant layer by layer. And sometimes this can create varying strength in different directions. Like it might be stronger horizontally than it is vertically.
Ah, so you wouldn't want to use it to build a skyscraper where the forces are mainly vertical. But we're talking about a skull here. It's not like this dog is going to be doing headstands all day.
Exactly. It's all about context. And in this case, the researchers, they took that potential for anisotropy into account when they were designing the implant. They made sure it was strong enough to withstand the types of forces it would experience in that specific location within the skull.
So they factored in the dog's lifestyle, its anatomy, the properties of the material, and they were able to create this custom-fit solution that really worked. It's like architectural engineering, but for skulls.
Precisely. And that's what's so cool about this technology, right? It's not just a one-size-fits-all solution. It requires you to really understand the materials, the printing process, and the specific needs of the patient to create something truly effective.
It's like this perfect storm of science, technology, and a little bit of artistry. But anisotropy aside, were there any other potential limitations with this material extrusion method that they highlighted?
Yeah. They did mention surface finish as another factor.
So,
Material extrusion, while it's very precise, it can sometimes result in a slightly rougher surface compared to some other 3D printing techniques.
so not exactly the smooth, polished finish you might get from a machine-milled piece of metal.
Exactly. And while that's usually not a big deal for a lot of applications, when you're talking about something that's going to be implanted in the body, you really want to minimize any potential for irritation or complications.
Totally. You don't want any rough edges rubbing the wrong way, so to speak.
Yeah.
So how did they address that? Did they take out the sandpaper and start polishing?
Well, for this case specifically, the researchers said the surface roughness was well within the acceptable limits for medical implants.
Okay.
But they did mention that sometimes you might need to use additional post-processing techniques, things like polishing or coating, to get that desired smoothness.
Ah, so a little spa treatment for the implant before it goes into its new home. But it does seem like, even with these kind of minor quirks, the potential benefits of this technology, I mean, they really do outweigh the limitations, don't you think?
I'd have to agree with that. I think this case study is a powerful testament to the power of innovation and collaboration, this willingness to push the boundaries of what's possible in veterinary medicine.
Absolutely.
And as we continue to explore and refine these technologies, the future is looking pretty bright for our animal companions.
It's a good reminder that science never stands still. It's always evolving, always seeking out those new solutions, and always striving to improve the lives of those around us, furry or otherwise.
But speaking of pushing boundaries, I did want to touch on one more aspect of this case study that I think is really important to consider, and that's some of the ethical considerations surrounding this type of really advanced veterinary care.
That's a crucial point, because when we're talking about procedures this complex, this advanced, this expensive, it really does beg the question, where do we draw the line?
That's the crux of the matter, isn't it? We've got this incredible technology that could potentially alleviate suffering and really improve the quality of life for so many animals.
Right.
But at the same time, it's not a magic bullet, and it's definitely not accessible to everyone.
Exactly. And that's what gets me thinking about the potential for disparities in care. We don't want to be in a situation where only those who can afford these cutting-edge, really expensive treatments are the only ones who can get them for their animals.
Right.
While others are left with very few options.
Absolutely. And it goes even beyond just the financial side of things, too. There are ethical considerations here about informed consent, making sure pet owners really understand all the risks and benefits, especially with procedures that are still relatively new and constantly evolving.
Right.
It's a lot to think about.
It is. It's a lot to weigh. The potential benefits versus the risks, the financial implications, are we doing the right thing? It's a conversation that needs to extend beyond just the veterinary community and involve pet owners, the public, everyone, really.
100%. Transparency and open communication are going to be key in all of this because, like with any new technology, there will be a learning curve for both vets and the public.
Absolutely.
It's about finding that balance. We have to embrace this innovation, but also make sure it's being used ethically and responsibly.
100%. But setting aside these broader ethical questions for a moment, I have to say this case study really highlights the incredible ingenuity and dedication within the veterinary field.
Oh, absolutely. I mean, this wasn't just your everyday surgery. This was a team of experts pushing the boundaries of what's possible, combining cutting-edge technology with their own unique skills and expertise to give this dog a fighting chance that it wouldn't have had otherwise.
And that's what makes this whole deep dive so inspiring, right? It's a powerful reminder that science is a constantly evolving journey, and that sometimes it leads to these absolutely incredible breakthroughs that have the power to change the lives of both animals and humans.
It really gets you thinking about what the future holds, right? Like, what other seemingly impossible cases might we be able to solve using things like 3D printing and other new technologies as they emerge?
It's a question that sparks so much excitement and curiosity. And honestly, the possibilities seem kind of endless when you think about it. Custom-designed implants, bioprinted organs.
I know, it's amazing.
It's an incredibly exciting time to be an animal lover, that's for sure.
Couldn't agree more.
Well, on that note of optimism and wonder, I think it's time to wrap up this deep dive.
From Vet NeuroJar, keep those minds inspired, hearts light, and tails wagging.